Most neural networks fall into two categories: models that learn representations and models that generate new data. Let's look at 7 of the most important types. Start with the simplest design, the feedforward network. To make a prediction, values flow one way, from the input layer through the hidden layers to the output. It handles tabular data for classification and regression. However, it often struggles with images, because what a pixel means depends on the pixels around it, and a feedforward network treats every pixel as unrelated. A convolutional neural network, or CNN, solves this by sliding one small filter across the image to find a single pattern, like an edge. Its output is a feature map of the edges, and the next layer filters that to find shapes and then whole objects, which is how object detection works. Next, sequential data brings a different problem. Take a sentence where the order carries the meaning, and each word depends on the ones before it. A recurrent neural network, or RNN, passes a hidden state from one step to the next, so every step builds on the last. Unrolled in time, it updates that state one word at a time, a running summary of everything so far. But that memory fades over long sequences, and each step waits for the one before it, so training is slow. Transformers avoid both problems by dropping the loop. Every word is processed at once, and attention lets each one look directly at every other word. So a word at the end of a page links back to the start, and transformers train on enormous amounts of text. This powers large language models. So those 4 networks all learn representations, and the next 3 generate new data. First, an autoencoder is a compressor shaped like an hourglass. An encoder squeezes the input into a small bottleneck, and a decoder rebuilds the original. But the bottleneck is too narrow to copy the input, so it keeps only what matters. The rebuild loses the fine detail but keeps the structure. Next, a generative adversarial network, or GAN, trains 2 networks against each other. A generator invents fakes, and a discriminator tries to catch them. They both compete and improve until the generator creates realistic images. So when training is complete, the generator can create faces of people who never existed. Next, diffusion models take a slower route. In training, they add noise to a real image, and the model learns to remove a little at a time. To generate, it starts from pure noise and repeats that small step many times, guided by your prompt, until an image appears. So to sum up, feedforward for independent features, CNNs for grids-like images, RNNs and transformers for sequences, and autoencoders, GANs and diffusion models to compress or create new data.